Hi everyone! In this video I'm going to talk about a tricky topic, which is how to choose your light source based on their technical specs. If at any point in time you were trying to find some low budget kind of light source, you were for sure struggling with understanding what's the difference between watt, lumen and lux. And in this video I'm going to show the mathematical comparison between these numbers and also give some cases when you should look a little bit beyond the technical specs. And the best part, I will give you a magical formula that allows you to calculate and compare all these characteristics across all types of devices with any camera settings. I'm going to illustrate the case with the three light sources I have right here. One is the fluorescent light bulb, one is the LED light, and one is the on-camera speedlight, which in this case is Canon 580EX. If you would go online right now and search for the description of each of these items, you would find something like this for the fluorescent lamp: 135 watt, 6000 lumen. For the LED, the description is 150 watt, 6.9 thousand lux at 0.5 meter. And for the speedlight, you will find just the guide number, which is 58. So how do we make sense of all of these numbers and which of them are important to us? First of all, let's talk about wattage. This is one of the most misinterpreted characteristics of the light source. You will find the wattage written in the description of nearly any continuous light source like the fluorescent light bulb or LED. The number of watt basically tells you the power consumption of this device per second, which means that this lamp will consume 135 joule per second and this lamp will consume 150 joule per second. The number of watt does not itself tell you the intensity of the light output that you will get. So why is it important for photography? It really isn't. It only tells you what kind of adapters can you use with your light source to not overwhelm and not melt the adapter itself, and how much devices you can connect simultaneously in your room if you are creating a home studio to not cause a short circuit out of overwhelming your power grid. You can very approximately transform the power consumption of your light into the light output. But this output would be very different for different types of hardware you're using. If you're talking about very basic light bulb, the light output out of 1 watt will be about 12 lumen. Lumen is a unit of measuring the amount of light. For the fluorescent light bulb, this number will be several times higher, and for the LED, for the modern LEDs, the output of the light can be several hundred lumen per 1 watt of energy. Can you use the number of watt in the description of the device to understand how powerful your light output will be? Not exactly. You can only expect linear dependency between increasing wattage and increasing light output if you're talking about same technology. But you cannot do such comparison between two different types of hardware. Now, what about the speedlight? You will never see the wattage written in the description of the speedlight, and that's because wattage describes the amount of energy consumed per second. The speedlight does not measure the power consumed per unit of time. It calculates the total power produced by the flashlight per one image. And for the Canon 580, this ranges between 60 to 80 watt second, which is the amount of energy in other units is called joule. You cannot really convert watt second to watt because the speedlight will never work during one entire second. First of all, it will overheat. Second, it's not technically possible because the speedlight has so-called recycle time, which is the time that speedlight takes to recharge after every flash in between several images. Now, what about the actual amount of light emitted by the light source? The amount of light, or in other words, luminous lux, is using the unit called lumen. Lumen is the amount of luminous energy produced by a device per second. Again, by definition, this can only be applied to continuous light sources because the speedlight does not have any specs that are dependent on the time. As I mentioned in the beginning, the amount of lumen is written only for one light source out of 3 that I have, which is a fluorescent light bulb. And it says that it is emitting 6,000 lumens. What does it mean? It means that during 1 second, the slide will emit 6,000 lumens second of light. If we set the shutter speed to a shorter duration, like 100, 200, the number of lumen will drop proportionally. For 1 to 100 will be 60 lumens a second, for 1 to 200 will be 30, and so on. So what's the problem with this measure and why it isn't enough for us to compare all the types of light sources out there? The problem is that the amount of the light emitted by the light source does not guarantee that all this light will reach your subject. In case of this light bulb, we'll see from the shape that the light will be distributed uniformly in all directions from this light bulb. In comparison, the more focused and the more directed LED light bulb will have all of this light directed towards one side. There is two extremes that you can compare to understand the principle behind the light distribution. One extreme is a light bulb that spreads light absolutely everywhere, and the second extreme is a movie projector, which is spreading all this luminous energy in a focused light beam towards your subject. So if you would have two devices, like the light bulb and the movie projector, emitting the same amount of lumens, you will have a very different effect on the subject, even if you take a photo from the same angle or the same location. The image resulted from the light bulb will be much less brighter than the one resulted from the device producing the light beam like a projector. Now, how do we account for the factor of different type of light distribution? There is a very convenient metric to do that. It is called illuminance. Illuminance is a number of lumen distributed per 1 square meter of the surface. It means that if I have my lamp next to the subject, the amount of light that will reach the plane at a specific distance from the light source will be calculated and the amount of lumen per square meter. This number is usually supplied with the distance at which the light is being measured. In the case of this LED lamp, it is written that it has 6.9 thousand lux at 0.5 meter. It means that the amount of lux was calculated when the light source was half a meter away from the subject. Now, if we move the light further away, to calculate how much light we will lose, we need to remember the inverse square law, and I really hope that you already heard about it before. The inverse square law tells us how to calculate the connection between the distance between the light source and the subject and the amount of light that will be gained or lost while moving the light further away or closer to the subject. From the inverse square law, we can calculate that when moving the light source 2 times further away from the subject, the brightness of the light will drop 4 times. When we move the light 3 times more further away from the subject, the light will drop 9 times. It means that having 6.9 lux at half a meter distance, moving the light 1 meter away will have the intensity dropping 4 times, and we will have only 1.7 lux at 1 meter distance. Now, this is really hard to apply this measure to this light bulb because it's not very easy to calculate how light is being distributed across space. The last characteristic that we are going to talk about is the guide number written on the speedlite. Usually, the guide number is encoded already in the name of the model. In this case, I have 580EX, so the guide number of the speedlite is 58. What is a guide number? Guide number is literally a product of the camera aperture and the distance at which the light source can be put away from the subject to have the subject correctly exposed. Now, using the guide number, it's easy to calculate how far away you can move your light at its full power given the camera aperture. So at the aperture 20, we have to move the speedlight 2.9 meters away. At the aperture 10, we can move it 5.8 meters away, and so on. The guide number is also supplied with the camera ISO settings and the speedlight zoom level that the guide number has been tested with. So in this case, the guide number 58 has been tested with ISO 100 and the zoom level 105 millimeters of the speedlight. The zoom of the speedlight is a feature that, in my opinion, is not really widely used. But basically, it works the same way as the camera lens. It allows you to make more focused light beam at the higher zoom level or the more spread out light beam at the lower zoom level. Now we went over 4 types of characteristics. We went over the power consumption measured in watts, the luminous flux or the amount of light measured in lumen, the illuminance measured in lux, and the guide number that doesn't really have units. Now, how do we put all these numbers together, or if it's really possible? It took me a little while to come to this conclusion, but the conclusion is really simple. To mathematically be able to compare all these types of light sources, we have to look at the device that is already measuring the correct exposure of the image for us. And this device is called a light meter. There are several types of light meters, and the one that's of interest to us is called the incident light meter. The incident light meter is measuring the amount of light reaching your subject. Now, how is this device calibrated? There is a very convenient formula for that. The formula takes into account both your camera settings, like aperture, ISO, and shutter speed, and also the amount of light that's reaching your subject, which is illuminance measured in lux. If we shuffle this formula around and eliminate the time factor, which is not really suitable for the speedlight, we can come across a different measure called luminous exposure. Luminous exposure is measured in lux second. And for the sake of experiment, we're gonna fix some of the camera settings across all of the devices. We're gonna set the aperture to 20, ISO to 100, which will give us 1000 lux second of the luminous exposure to have a correctly exposed image. Now let's see how do we adapt all of these devices to achieve a correctly exposed image and get exactly 1000 lux second of luminous exposure at our image. This is my favorite part. First, let's look at the speedlight. The guide number tells us exactly, at full power of the speedlight, what distance should we keep from the subject at the given camera aperture. At the aperture set to 20, the distance from the subject should be 2.9 meters. In our case, I'd like to move it a bit closer to 1 meter in order to be able to compare with the other light sources. How do I recalculate the amount of light? Following the inverse square law. When we decrease the distance 2.9 times, the illuminance will grow 8.4 times. And luckily, the speedlight allows us to regulate the amount of power, and if we move the speedlight 1 meter away from the subject, we can just set it to the 1/8 of its power for the subject to be correctly exposed. The second one is the LED. The LED, as we calculated previously, will have the illuminance at 1 meter away from the subject equal to 1.7 thousand lux. This means if we put this number in the formula of luminous exposure, which in our case should be equal across all devices to 1000, we can calculate a shutter speed that we need to set our camera in order to get the same exposure as the speedlight. And in our case, the shutter speed will be equal to 0.6 seconds. The third device, which is a fluorescent light bulb, does not really have any information about the light reaching our subject. It does not have the data about illuminance. It doesn't have the data about the luminous exposure. Therefore, we will need to calculate all of it ourselves. Now let's do a little experiment. I created a small composition in some kind of black box, which will isolate the light, possibly reflecting from the walls or from the ceiling. I placed the speedlight 1 meter away from the subject, provided the camera settings, the aperture 20 and ISO 100, and the shutter speed, which doesn't really matter in this case, but I set it to 1 divided by 100. And this is a result of the supposedly correctly exposed subject. Second, we're going to test the LED light that comes with its own modifier in a different color temperature, which is white, cold, and warm. We're going to set it to the white color. The camera settings would be the same except the shutter speed, which we will set to 0.6. Now, with this value of the shutter speed, we have to make sure that the ambient lighting is not affecting our image. So we're going to make a test shot without the LED light on to make sure the test shot comes out completely black. Now we can turn the LED on and make the actual test shot. I was also curious how much the native modifier that comes with LED does decrease the exposure. So I removed it and made another test shot, and indeed the result was much visibly brighter. Also, this was the only light source out of the three that allowed for a different color temperature. So I've tried to make it closer to the one of the speedlight and set it to cold temperature. And indeed, the temperature was much better looking, but the brightness without the native modifier dropped back to the level of the one with modifier, but with a white temperature. And the last one is a fluorescent light bulb, which I tried to place exactly 1 meter away from the subject, but it's hard because it has a long shape. I have removed all the ambient lighting at all because the shutter speed would be much longer and it will definitely affect the image. And the shutter speed eventually was found with trials and errors, and at the shutter speed 4 seconds, it gives the acceptable exposure, similar to the ones we had with LED and speedlite. Now let's look at the results. In all three cases, we've been able to achieve the same luminous exposure of the image, which equals to 1000 lux second. We've been using the same camera aperture and ISO settings, and we've put the subject at the same distance away from the light source in all three cases. The only variables that we've been modifying are the power settings of the speedlight and the shutter speed for each of the light bulbs. Now just a few words about the side effects that go beyond the specs that you can see in the description. First of all, the compatibility with different modifiers. When you are using basically any sort of modifier, most likely the amount of light that the device is producing as a bare bulb will drop. If you're using the reflector dish, if you're using the snoot, the amount of light reaching the subject will be much lower, and this is something to keep in mind. The different shapes of the light sources might also be more suitable to different types of modifiers. For example, the light bulb like this will work just fine with a softbox that has all the reflected surface inside and will bounce back the light to the diffuser plane. While this lamp might work much better with the grids or just by itself. The speedlight out of all of three is the best compatible with all available type of modifiers because you can easily find the adapter to the Bowens mount, and from the Bowens mount you can use almost any adapter you like. Last but not least, the power settings. This light bulb is a very basic one which only works at full power. The speedlight has a very fine-grained step and you can calibrate really nicely how much powerful you want your speedlight to be. And this light has not only the power settings that you can choose from 0 to 100%, you can also choose the color temperature of it between the cold, white, and warm colors. But don't forget that the color temperature will also affect the illuminance, and the very warm or very cold light might decrease the amount of light significantly. So finally, what practical knowledge can you take away from this video, and how does it help you choose your light source? First, the wattage is not that important. Number 2, pay attention to the shape of the light source and keep in mind the modifiers that you would like to be using it with. Number 3, look at the light output of the device. This might be expressed either in lumen or in lux, and whichever number would be of interest to you depends again on what modifiers you'll be using it with. And if you want to go full nerdy about it, you can use the two formulas, one for the calibrating of the incident light meter and the second of the inverse square law. And these two formulas will help you calculate any number you want between the camera settings, the light characteristics, the light position, and so on. I will be really happy to hear any feedback from you about the possible mistakes in my calculations, but also if this material has been in any way useful to you. And if you have conducted any similar experiments, please share.